All right, so let's first have a look at angles with crossing lines. So here I've got an X. So the angles with crossing lines will always look like an X. So when we've got, so there is our X, okay? The reason for this is vertically opposite. So the two angles on either side of the X, like the 1 and the 3 there, is equal to each other. So vertically opposite angles are always equal. So this one, the 2 and the 4, is also equal to each other because they're also vertically opposite. So this is basically when you've got an X like that, where the two lines are straight. So there's only two lines crossing and they must be straight lines. Then we can say that something is vertically opposite. So let's quickly have a look at the next one. Okay, there we go. So the next one is angles on a straight line. So angles on a straight line, sorry, I'm new to this recording thing, so on my screen. So let's see here, angles on a straight line. So it's a straight line. So the lines must be straight. And then there's another line that crosses it. So this line can cross it completely like that, or it can just be like the drawing that I made here. Then the two angles or three angles, it could be like this, and then it's three angles, 1, 2, 3. So those angles are all equal to 180 degrees. So angles that's equal to 180 degrees, we call supplementary angles. So how to know if it's angles on a straight line is if you've got these angles and you connect them like that, there and there, then this is a half a circle. So if this is a half circle, then it's angles on a straight line. So sometimes you get something like this. Let me just go back. So sometimes you get something like this. Let's just continue this line here. And then there's another line. So this one and this B2 that I've got here is not angles on a straight line because I can't connect them and they don't make a half circle. So to know whether you can use this, you must have a half circle. And then how to use this, so you say this one here, B1 plus B2 equals 180 degrees, like I've got over here. Okay, so that is angles on a straight line. These two you're going to use quite a lot. I just quickly want to open my other worksheet. I'm always struggling if the screen is turned. Okay, let's see. Here we go. All right. Now we have a sum like this. All right. Let's say we've got two lines and a line crossing it like that. Okay, so you'll often see things like this because we're going to look at parallel lines later. So let's say this one here is 60 degrees. And this one's X and Y and Z. And let's put in a and a B here as well. Okay, so we've got this 60 degrees and we have to figure out the X, Y, and the Z. So if we start by looking at the 60 degrees and this one right across it. So you can see that this is an X. So whenever you've got an X, we can use vertically opposite angles. So we can say x equals 60 degrees, and you must always write a reason, otherwise you don't get the mark. So our reason is vertically opposite. You can just write it like this in an abbreviation, vertically opposite. So now we can work out the z and the y, because now we've got the x. So if you look here, then these two, like that, makes a half circle. So it's angles on a straight line. So angles on a straight line would be, I'm just quickly going to erase this to give myself space. There we go. So we want to say the y plus 60 degrees is equal to 180. Okay, so they're 180 together because it's a half circle, but our reason is angles, so we can just go like that, angles on straight, so we can just abbreviate it, line. Angles on a straight line. Okay, but we haven't worked out y yet. So now we can take this x, this 60 degrees over to the other side, and then it becomes minus 60 degrees. So then y equals 180 degrees minus 60, and 180 degrees minus 60 is 120. So your final answer would be y equals 120 degrees. So let's just put that in here. So we've worked out x is 60 and y is 120. So now to get to the z, this is also making an x. So we can use vertically opposite angles again. So to get from the y to the x, y to the z, it's z equals the y, they're the same, which equals 120 degrees, because we just worked that out. And our reason is vertically opposite angles. Vertically opposite. So we've worked those ones out. Okay, so let's just get rid of this mess quickly. How can we work out the A and the B? So over here, I didn't tell you that these lines are parallel because I'll get to parallel lines in the next video. But I didn't tell you they're parallel. Only if you see that and that, then it's parallel. But I didn't give you that. So you can't get to these angles because it doesn't make an X with any of these, and it doesn't make a half circle with any of these. So I actually just put that in to show you that we can't get there because we don't have a half circle and we don't have an X. Okay, so let's do one more. All right, so let's go like that. And then this one is X. And this one is 2x plus 20 degrees. Okay, I actually just want to write it in a different format because there's different formats of doing this and I want you to get used to it. So I can label these lines A and B, C, D. So let's put a O there in the middle and call this O1, O2, O3, and O4. So then I can tell you that O1, so I put like a little hat on it to show that that's where the angle is. So O1 equals x plus 30 degrees. And then I also tell you that O2 is equal to, let's write it here, O2 is equal to 2x plus 50 degrees. Okay, that's what I give you. Now my question is, solve for x. So we want to solve x. Okay, I'm actually going to try the text thing and see how that works. All right, so I have no idea how it works. All right. So if we've got, this is what we're given. So here we have an x, which means we can use vertically opposite. So these two are opposite each other, so we can use vertically opposite. But what we have is O1, and we've got this one, and we've got this one. So we've got an x and we've got straight lines, but these ones are not vertically opposite because they are together, they make a half circle. So let's use that. So if we have the one angle, O1, plus the other angle, O2, is going to equals 180 degrees. And our reason for that, so you have to write the reason, is angles on a straight line. Okay. Then we have to fill in our details. We have to fill in the actual numbers. So the numbers that we've got is O1 is x plus 30. And O2 is equal to 2x plus 50. And that gives us 180 degrees. Just want to make my 5 better there. So that is 180 degrees. So now we just solve the algebra. So we take we want to get all the numbers to the one side, so we throw that over, and we keep all the x's on the other side of the equals. So here we've got x plus 2x is 3x. And we take those ones to the other side, so we've got 180 equals 180, and remember, if we throw them over, they become negative. So minus 30 minus 50. So we've already written the reason when we said that. So we don't have to write the reason again. Now we just do the calculations. So we've got 3x equals, and 180 minus 30 minus 50 is 100. Then we have to get rid of the 3, so we divide it away. Divide by 3, divide by 3. And then our x is going to be a fraction because 100 divided by 3 is going to give us not a whole number, but a fraction. So you can do that on your calculator, and the answer is going to be 33.3. Well, 0.33. So that is the value of the x. So the question was not what's the angle, the question is what is x? So we've done that, we've worked out the x by using angles on a straight line is 180 degrees. All right. Now, let's do another one here. So now I change the question and I say, all right, work out for me what is O3. So O3 is the same as O1 because these two are opposite on the x. If these two lines make an x. So it's vertically opposite. So we said that the x, O1, was equal to x plus 30 degrees. So so now O3 is also going to be x plus 30 degrees. But we did work out our x, so we can just use that. So it's 33.33 plus 30, because that's what we just worked out the x is. So our answer is 63.33. So that is O1. Okay, then for O4, if we want to work that one out, we can say that O4 is equal to so O4 is equal to O2 because they're opposite on that two lines crossing, that X shape, and we've got, so the reason is vertically opposite. So the O2 we said was equal to X plus 50. Was it 2X plus 50? Yeah. And that was the O2, but it's equal to the O4. So the O4 is the same as the O2 was. Okay, we've got the X, the value of X, so we can just work that out. So we've got 2 times 33.33 plus 50. Because if we've already worked out the X, then we can just use that value. And you can do that on your calculator, but that's going to be 2 times 33.3 is 66.66 plus 50 degrees, and that's going to give us 116.66. So that would be the value of O4. All right. I've got another couple of examples here. Let me just open them for you. Vertically opposite, yes. Okay, kom nou. There we go. All right. So here we have these angles here, and I just want to look at the vertically opposite ones. Okay, so that makes an X there, which means that X is going to be equal to A. And the Z is going to be equal to the Y, because they're also vertically opposite. With this one here, we've also got an X there. The two lines crossing makes the X shape. So this B is equal to this E, because it's vertically opposite. And then this D is equal to this C, because it's vertically opposite. Okay, and the angles on a straight line would be, here I've got some examples of that over here. So B plus C See, that makes a half circle. So it's 180 degrees, angles on a straight line. And we've got the y plus the a also makes a half circle. So it's angles on a straight line. And for the last one I've got here, x and z makes a half circle. So it's also angles on a straight line. All right, so I will make you another video to explain sorry, I'm just being ridiculous with my recording things here. I'm not used to doing it on my phone. All right, so I'll make you another video that will explain the parallel lines. But I hope that helps with vertically opposite and angles on a straight line.